Okay, thank you very much for coming over here. Okay, so today we will start our class, and we know that uh, what we discussed is about Modi's method. In the Modi's method, in the last problem, we discussed so much. So, second cycle over. Now we have to go to the third cycle, and we have to find whether that is the least cost or not. Okay, that is what our aim now. So, let me open my screen, and I want to share my screen now, and that screen consists of the continuation of the last problem. Okay, so we have to continue with the last problem, and this is what sharing of my screen. Okay, this is what my screen. I do want to this problem. I already finished particular problem. Now look at this is the problem we started with 2 days back. This is the original problem. We done it by northwest corner rule, and then the transportation cost was 128. 128 was the transportation cost. Okay. Then afterwards, we checked the net values. After finding out the fixed cost, we checked the net values, and some negative value we got, some positive value we got in the net values. Then positive is here. We started this drawing a loop through corner points of the base corner points as, and then we gave theta minus theta for the corner cells, and then theta is equal to look at that, theta is equal to minus theta assigned cells. We have taken this and this and this. Among these, what is the um, basic values we identified? The basic values are 6 to 1. Okay, right. Then among them, which is the minimum 1, then we substitute theta is equal to 1 there, theta is equal to minus 1. So we got that we got here 6 minus theta 1, 5 we got, and here 8 plus 1, 9 we got, here 2 minus 1, 1 we got, and here 14 plus 1, 15 we got, and then here 1 minus 1 0 we got, like that we got a new arrangement. For that new arrangement, we play the uh, transportation problem, and also what is that called, the solution set, and we got that solution as yeah, this one. Okay, see here, look at that. This is what we got as a solution set there. So something is going on there. Does not have that particular. I will rub that. Okay. So now some problems. And we got this uh, particular where that where should not be there. This also should not be there. Okay, here one should come there. Here afterwards we'll fill up this. What is the wrong with the software is not working, I think so. Okay, and then here nothing is there, and then here we have one. Okay, okay, so this is what we got the assignment. Samikite, so 5, that is x11 equals 5, and x12 9, and here x22 1, here x what is that, x2 3. 23 is equal to 15, and here x31 is equal to 1, and here x3 4 is equal to 4. This is what is called this is what we call the assignment. For this assignment, we got the total transportation cost as 5. What we transport the computers at the cost of one cost transportation cost is rupees 6. Therefore, 5 into 6. That is what 5 we have here. 9 into 4. 9 into 4. That's what we have here. 1 into 9. That's what we have here. 15 into 2 we have here. 1 into 4 we have here, and 4 into 2 we have here. If we add them, we are getting 117. So we got just before that the transportation cost by that method, just before the northwest corner method, we got that is 128. See here, 128. Now after this cycle, that is drawing the loop and changing the theta minus theta value, what value we got is that this value we got 117. So we see the some difference. It's coming down. Am I correct? From 128 to 117 is coming down. Some savings for us. Okay, so is this the final value? Is this the optimum value? That is what with that particular question we stopped and went out. Is this the final solution? Is this the optimum? Is this the minimum among minimum? With that we stopped. Okay, now we have to go for that. So for that, what we have to calculate. We have to calculate what is called the fixed cost and net values, and everything we have to calculate. If in the net values all are negative and 0, that's all. This is a least cost. If any positive number comes, then again we have to go for drawing the loops, and then assigning the theta and minus theta, and also giving the value for theta. These are the things that we have to do here. Okay, so our first aim is that to find the fixed cost for the new table, this table, for basic cells. Okay, right. Now what are the basic cells? This one, C11 is the basic cell. Here C12 is the basic cell, and C22 is the basic cell, and C23 is the basic cell, and C31 is the basic cell, and last one basic cell is C34. Okay, so these are the basic cells we have here. For these basic cells, we have to use the formula Cij equals Ui plus Vj. This is for basic cells. We have to use this particular formula. Okay, right, for basic cells. So here, what are the basic cells? C11 is the basic cell. So C11 equals U1 plus V1 equals 6. Right. Then C12 is the next basic cell. C12 is equal to U1 plus V2. So in that cell, what value we have? 4 rupees is the transportation cost from here to there. Am I correct? So that is what we are writing here. Similarly, 6. 6 is the transportation cost from this place to this particular destination. Therefore, that 6 we have written here. C11, the transportation cost in the basic cell. Now, coming to the next basic cell is C22. C22. C22, how can we write? U2 plus V2. U2 plus V2. But what is the transportation cost there? It is 9 rupees. So 9 rupees we are writing here. The next transportation, basic cell is what? This one. That is 2, 3. So 2, 3 is the basic cell. 2, 3. So C23 equals U2 plus V3 equals 2. So C23 equals U2 plus V3 equals 2. Okay, right. So this is what 2, the transportation cost per unit computers from here to there. Now next cell is what? C31. C31 is the next cell. What cell? Basic cell. So C31 is equal to U3 plus V1, And what's the transportation cost per unit compute?